To begin our journey, we must first understand the foundations of time travel. These foundations are rooted in concepts that might sound straight out of a sci-fi novel, but in reality, they stem from theories proposed by some of the world's most brilliant minds. Firstly, let's consider the theory of relativity, put forth by none other than Albert Einstein. This revolutionary theory transformed our understanding of time, suggesting that it's not a constant but rather something that can be affected by gravity and speed. Imagine, if you will, a clock on a spaceship moving near the speed of light. According to Einstein's theory, this clock would tick slower than a clock on Earth. This concept, known as time dilation, is a cornerstone of time travel. Our next stop on this journey through the foundations of time travel is the mysterious world of wormholes. A wormhole, in theory, is a sort of shortcut through space-time, connecting two distant points like a cosmic bridge. If we could harness the power of wormholes, we could theoretically step from the present into the past or future. Lastly, we come to the concept of space-time. Picture the universe not as three separate dimensions of space and one of time, but rather as a four-dimensional fabric known as space-time. This fabric, according to theory, can be warped and twisted by mass and energy, opening up the potential for time travel. These theories, revolutionary for their time, have paved the way for the concept of time travel. They've shifted our perspective, transforming time travel from a fantastical dream into a theoretical possibility. As we continue to explore these concepts and push the boundaries of our understanding, who knows what discoveries await? Perhaps one day the concept of time travel will shift once again, this time from theory to reality. Time travel isn't as straightforward as it seems. It's riddled with paradoxes and mind-boggling implications. Today we'll unravel some of these paradoxes, delving into the grandfather paradox, the bootstrap paradox, and the butterfly effect. First, let's dive into the grandfather paradox. Imagine you invented a time machine and traveled back to a time when your grandfather was a child. Now, what would happen if you accidentally caused an event that led to your grandfather's untimely demise? This would mean your parent, and subsequently you, would never be born. But if you were never born, how could you have traveled back in time to cause the event in the first place? This circular logic is the essence of the grandfather paradox, a classic example of the complexities of time travel. Next, we explore the bootstrap paradox, named after the phrase pulling oneself up by one's bootstraps. The bootstrap paradox occurs when an object or piece of information sent back in time becomes trapped within an infinite cause-effect loop, where the item no longer has a discernible point of origin and exists without being created. Imagine a book that is sent back in time and found by a young author who then copies it word for word and publishes it. In the future, it is then sent back in time again. The question is, who wrote the book? Lastly, we delve into the butterfly effect, a concept derived from the world of chaos theory. It proposes that small changes can lead to drastic shifts in a system. In terms of time travel, it suggests that even the smallest actions in the past could drastically alter the course of history. Picture a scenario where a time traveler steps on a prehistoric butterfly. This seemingly insignificant act could set off a series of events that drastically change the present. These paradoxes pose profound questions about the nature of time and our place in it. They challenge our understanding of cause and effect, presenting scenarios where cause can follow effect, where objects can exist without being created, and where minor changes can have monumental impacts. As we journey through the realm of time travel, we must grapple with these paradoxes, and perhaps in doing so, we may come closer to understanding the true nature of time itself. The concept of time travel has captivated the human imagination for centuries. It's a theme as old as time itself, found in the annals of ancient myths, the pages of literature, and the heart of popular culture. In ancient Indian epic, the Mahabharata, King Raivata Kakudmi traveled to a different realm to meet the creator Brahma, only to return to Earth ages later. In Japanese folklore, we find the tale of Urashima Taro, a fisherman who visited a palace under the sea and returned to find 300 years had passed. These stories represent early human curiosity about manipulating time. Fast forward to the 19th century, and we encounter H.G. Wells' groundbreaking novel, The Time Machine. It introduced the idea of a vehicle that allows an operator to travel purposefully and selectively in time, igniting the imagination of millions. This was a pivotal moment in the history of time travel, transforming it from myth and magic to a concept rooted in scientific possibility. Throughout the 20th century, time travel became a staple of science fiction. It's hard to imagine popular culture without the likes of Doctor Who's TARDIS, the DeLorean from Back to the Future, or the Time Turner in Harry Potter. Each of these examples demonstrates the human yearning to control time, to correct past mistakes, or foresee future outcomes. Even today, as we delve deeper into the scientific possibilities of time travel, this theme continues to permeate our stories and our dreams. It is a testament to our collective longing to explore the mysteries of time, to understand what has been and what is yet to come. From ancient myths to modern science fiction, these stories reflect our enduring fascination with the mysteries of time. They serve as reminders that while we may not yet be able to travel through time in the physical sense, we are always journeying through it in our imagination, in our stories, and our relentless quest for knowledge. While we don't yet have time machines, the future of time travel is not as far off as you might think. As we stand on the brink of scientific breakthroughs, we continue to push boundaries and challenge the very fabric of reality. In the realm of quantum physics, cutting-edge research is being conducted that could potentially pave the way for time travel. Scientists are delving into the mysteries of quantum entanglement and superposition, phenomena that hint at the possibility of time manipulation. Experiments with particles are also revealing fascinating insights. Take the case of quantum particles, which have been observed to exist in multiple states simultaneously until measured, challenging our understanding of linear time. Or the phenomenon of tachyons, hypothetical particles that are predicted to travel faster than light, potentially allowing for backward time travel. Moreover, ongoing investigations into the nature of black holes and wormholes could potentially offer a gateway to different points in time. Theoretical physicists propose that these cosmic structures might be linked through a network of wormholes, creating a sort of cosmic subway system for time travel. But it's not just about the science. Ethical and philosophical questions also abound. If we could travel through time, what would be the implications? How would we deal with the paradoxes? Would we have the right to alter the past or the future? The answers to these questions could shape the future of time travel and our place in it. Every scientific breakthrough brings us one step closer to unlocking the secrets of time. As we unravel these mysteries, we may find that time is not a linear path, but a vast landscape waiting to be explored. The future of time travel is a thrilling frontier, teeming with possibilities and potential. As we continue to push the boundaries of our understanding, we inch closer to turning this science fiction concept into a scientific reality.